So what about division? Well, here's a research note, or what people have compiled from looking at research. I mean, just recognize, and many of you can remember, at least when you were first in school, how much you struggled with long division, the standard division algorithm. Many students never master that. I mean, you can do year after year, worksheet after worksheet, and they just never get to the point where that makes sense to them, or that they can do it without making errors. And then it turns out that even those students who do master it, they don't really understand what they're doing. If you ask them, they just say, well, I do it because you told me to do it that way. I don't really understand why I'm doing anything. So they don't really understand why they're doing it or what the answer really is involved in. Some of them can master it and not even realize what kind of real-world context it takes to be division. So one of our colleagues typically says we do a lot of having kids know how to divide, but they never know when to divide. And so what have you really accomplished when you do that?
And now we're going to learn how to divide. It's a math problem, but we'll try our best to make it rhyme. Now let's divide 75 by 3. You gotta find out how many groups of 3 you'll need. 3 goes into 7 only 2 times. So you write the number 2 on the line
above the 7.
Multiply that 2 by the 3. 2 times 3 is 6, so write that underneath where the 7 is. And now it's time to subtract. 7 minus 6 is 1, so be sure to write that. And now it's time to bring down the 5 beside the 1. Now a 15 comes alive. And here's what the next step should be. 15 has how many groups of 3? If you know your math facts, you'll get it. 3 times 5 is 15.
There, we said it.
So now you write that 5 on the line right beside the 2 above the 75. Multiply the 5 times the divisor.
3.
That gives you 15, so you write that at the bottom of the problem. Subtract it from the first 15, and that leaves you with 0. No remainder to be seen.
Divisor, dividend, quotient, remainder. Divisor, dividend, quotient, remainder.
Sometimes there's a remainder. That means you had a little something left over. All you gotta do is put an R beside the quotient with the number after that, and then you're good to go. So now you know.
One reason that this might be happening is that standard algorithm, that standard long division algorithm, is so streamlined that really the people are, students when they're doing it, are ignoring any kind of place value understandings. And so it's so streamlined and compacted that it obscures the real relationships, the real concepts that are the basis of that algorithm. And so it's extremely difficult to ever get to the point where students will understand it. So the reason why we're saying this at the beginning is to try to get you think about how much do I want to hold on to and defend that standard long division algorithm, or might there be some other algorithms that will be more conceptual, make more sense to kids, be less stressful, don't make the kids think they're stupid because they can't ever get this. Maybe we need to look at an alternative, especially given this research. So again, the partial quotients is probably one that will be emphasized quite a bit, sometimes just to make the point that it is a nicer algorithm, doesn't cause kids problem. We call it low stress or low risk, and in some books it'll be called scaffolding algorithm. But it really is a partial quotient, very similar to what you do with partial products and partial sums and the other algorithms in the other operation. But this algorithm needs to be developed out of work with concrete materials in both sharing and measurement contexts, which you will have already made sense of what that is in prior work, using base 10 blocks, modeling it at a concrete level, and then demonstrating how the record of what you do when you're really making sense of it looks different than the standard algorithm. And so we get this other algorithm that can be unpacked and match up with what happens down at the concrete level. So it's much more meaningful.